Good morning, students. Welcome to live lectures of complex analysis. In this lecture, we'll discuss algebra of limits of a function of complex variable. So, in last class, if you see, we have discussed some basic definitions, like when we say that some set is bounded. Can you see the screen?
Yes, sir.
Okay.
Yes, sir.
Yes, sir.
Yes,
Yes,
fine.
sir.
Then we also seen what is meant by accumulation point. Then we have given equivalent characterization for closed set in terms of accumulation points and open set in terms of interior points. I asked you to solve for this second problem, exercise 2, which is a set is open if and only if it contains all its every point is an interior point of S. Okay. Whether you have anyone have doubt? Hmm? Whether you have any doubt? No doubt. Silent. Whenever we ask some question, silence. Then we have defined what is meant by function of a complex variable. Okay. And after that, we have defined limit of a function. Okay, where f is defined and some neighborhood, deleted neighborhood of. So if you want, you can write here. Let f be defined on some neighborhood, deleted neighborhood of z naught. Then limit of f of z naught is w naught if this condition is satisfied. Okay, then we have seen the geometrical interpretation, and we have shown that if limit exists, then limit is unique. Okay, and we have seen one example that iz bar of 2 upon 2 as z tending to 1 is equal to I by 2. Okay, this is all we see in last class. Now we'll check. We before going to this algebra of limits, we give one example, because last class we have seen example of a limit. We'll find now an example which limit does not exist. Okay, so we'll find a function. So you can say show that limit z upon z bar, this is z bar, okay, as z tending to 0 does not exist. So this z upon z bar is your f of z, as z tending to 0, this limit does not exist. Okay, so two ways we can show is one way of showing that if we get two different limits, then limit cannot exist. Okay, because we proved that if at all limit exists, then it has to be unique. Okay. Well, so the idea is, suppose assume that this limit exists, then so suppose limit z upon z bar as z tending to 0 exists. Then what is meaning of saying this? Then in some deleted neighborhood of 0, okay, this limit is unique, however z approaches to 0. Z means x comma y. Is that clear? So what you have to understand here is that if at all limit exists, then you can see that where is this is 0. Okay, so you have some neighborhood, so you can take some neighborhood around 0. Then in this, if at all this limit exists, then z tends to 0. That means whenever a z is close to 0, whichever way it may be. Okay, so whether it approaches, this is suppose your z, which is z tends to 0, or here, in whichever way, if it approaches to 0, then that limit should same. Is that clear? Yes or no?
Yes, sir.
So we say that something limit exists means around 0 if points are close to 0, approaching to 0 from right side, left side, or any way in this any direction, then limit should be same. But here we'll show that we'll take particular point, a particular point here. This is nothing but simply what is this point? Here y axis y element is 0, so it is, you can call it z is equal to x comma 0, and you take one point here which z, this is same as 0 comma y. So as y tends to 0, then z tends to 0. Similarly here, as x tends to 0, this tends to 0, right? Is that clear or not?
Yes, sir. Yes, sir.
Then
Yes, sir.
then limit of z tending to 0, z upon z bar is unique whenever z, you can call it say x comma y, tends to 0 in any direction, okay. So in particular we'll take these two. In particular limit of this function, which is z upon z bar, our z we will take here as x comma 0, okay. This approaches to 0 comma 0. Are you following? That means this is same as saying that what, as extending to 0, this should be equal to limit of z upon z bar, okay. Our z is 0 comma y tending to 0 comma 0. Is this step clear to everyone?
Yes, yes, sir.
So we are,
Yes, sir.
as z tends to 0 means z is x comma y, so x comma y tending to 0. So we are taking two particular cases. One is x comma 0, that means points on x axis approaching to 0, and similarly points on y axis approaching to 0, and of course they are inside this neighborhood, okay. But if you find, this implies what is this limit value? Here y is 0, here y is 0 or not? So this is same
Yes, sir.
as finding, if you write this z, which is x plus iy, and this is x minus iy, right? Similarly this is 0 comma y tending to 0 comma 0, this is x plus iy upon x minus iy, and left hand side y value is 0 and right hand side x value is 0, and left hand side it is same as x tending to 0. Is this clear? Yes or no?
Yes, sir.
And y is
Yes,
0,
sir.
so this is same as x upon x. Similarly this is y tending to 0, and x is 0 here, and this is I times y upon minus I times y, okay. So but what is this you will get? No matter, as x tends to 0, this value is 1 or not? Left hand side value is 1, right?
One.
And right hand
Yes,
side
sir.
what we are getting is
Yes, sir.
minus 1, of course,
Minus
which is
one.
a
-1.
contradiction, right? Which is not at all true, because 1 cannot be equal to minus. Is this clear? So this arises because we have assumed that
Yes, sir.
this limit exists. So therefore this cannot be true. That means limit z upon z bar as z tending to 0 does not exist. Okay, is this clear? Now take one exercise in this similar pattern and try. If you are not getting, I'll explain again. If you don't try, you are the final loser. You try and ask me, I am ready to explain. Show that this limit of f of z, which is z upon z bar whole square, the difference is z upon z bar. Is that clear? As z tending to 0 does not exist. You may think that this is similar to this one. Is this similar to this? The same approach won't work. Are you following? Why? Why the same approach doesn't work? Because you have a square, right?
Yes, sir.
Because square is there, you
Yes,
will
sir.
get 1 is equal to 1 both sides. Yes or no?
Yes, sir.
So what you have to
Yes,
do is,
sir.
you have to do in same way, same idea is same. Z tending to 0. So one you take as suppose something like x comma 0. So take one is x comma 0. Instead of taking another one is 0 comma y, and also take x comma x or x comma x. Are you following? That means what we are doing here is, if you take this one, then you take a point x z, which is x comma 0, and what is another one, x comma x. That means your x coordinate and y coordinate both are same. Is this clear?
Yes, sir.
Okay. So instead of taking one is on x axis and another one is on y axis, you take one is on x axis and another one is on like diagonal. Are you following? Hmm?
Yes,
So
sir.
you have to substitute these values, and as extending to 0 you find values, you will get different limits. Clear? Hmm?
Yes, sir.
Okay.
Yes, sir.
So try, you will definitely get, otherwise I'll help. Now to see the some properties of limit, we already know that, say already known, what we know is that in real analysis or calculus, limit of, you call it as anything, u of x comma y or f of x comma y, okay, in limit of functions in two variable. This is already known how to calculate algebra properties of this, that means sum of these limits and so on, okay, tending to x naught comma y naught. This is already known, and all other properties. Is that clear? Hmm? Yes or
Yes,
no?
sir. Yes, sir. Yes, sir.
So now we want to find the limit of the function. Instead of real valued, we want now function, complex function. Complex function means it is a function of complex variable. Okay. So find we want to find limit of f of z, where it is a complex function, where z tending to z naught, right? So how we'll do is, we'll try to have connection between this limit of f of z to limit of its imaginary and real part and imaginary part, which are real valued functions. Is that clear? What is our idea? Hmm? Is
Yes,
statement
sir.
clear? We will try to find the relation between limits of this f of z and limit of a real valued function, in terms of limit of real valued function. Okay, so for that, let what are all we know, z is equal to x plus iy, and f of z is equal to u of x comma y plus I times v of x comma y. Then z naught, which is x naught plus I times y naught, and w naught, which you call it as u naught plus I times v naught. Okay. With respect to all these notations, we can have then limit of f of z as z tending to z naught is equal to w naught, if and only if we'll try to give in terms of this its imaginary part and real part, if and only if limit of u of x comma y as x comma y tending to x naught comma y naught, this is same as your u naught, or you can call it u naught of x naught comma y naught. Okay, and limit of v of x comma y as x comma y tending to x naught comma y naught, this should be same as v naught. Is this statement clear? Hmm? Is this
No,
statement
sir.
clear? Any problem? Hmm?
Yes, sir.
This
All
gives
done.
relation between limit of a function of a complex variable and limits of real valued functions. Yes or no? Hmm? So if we know f of z is equal to w naught, then we know that limit of u of f x comma y is u naught, and limit of v of x comma y is v naught. Right? Proof is not at all difficult one. Okay. The proof is just assume, say suppose assume this and prove this, and conversely take this one and prove this. Okay, so suppose limit of f of z as z tending to z naught is w naught. Then we want to show that these two real valued limits, one is u naught and the other one is v naught. How will show something is limit of something is equal to, take an epsilon and somehow find a delta such that whenever this distance is less than delta, then distance will be less than epsilon. Is this clear? So start with let epsilon greater than 0. Our idea is somehow we should find a delta satisfying condition, right? But after this, how we will get a delta? What is given to us? This limit of f of z is equal to w naught is given, right? So therefore, by definition, what we know? Then there exists a delta greater than 0 such that what is the definition of limit f of z is equal to w naught?
Mod of f of z minus omega naught is less than epsilon.
Very good. So
Wherever
this is same as f of z minus w naught is less than epsilon whenever mod
z
minus z naught is less than delta. Right? We just simplify these things by substituting whatever we have given f of z, z, z naught, w naught. Then we will see what you will get. That is same as saying that mod f of z is u, you can write simply u plus iv. Okay, xy you write or not, it is understood. So u plus iv, that is our f of z, minus w naught, which is u naught minus iv naught is less than epsilon whenever z, which is x plus iy, z naught is x minus iy naught is less than delta, right? But that is same as if you write as real part, that means u minus u naught plus I times v minus v naught is less than epsilon whenever this is x naught. This is x minus x naught plus I times y minus y naught is less than delta. Is this clear? Yes or no?
yes, yes sir. Yes.
Yes.
This is what from this epsilon and given data we got this much information. Now what we want to prove? We want to prove that limit of u of x comma y is u naught as x comma y tending to x naught comma y naught, right? So what is meaning of saying that? In calculus, x comma y tends to x naught comma y naught means their distance is less than that delta. Is that clear? Yes or no?
Yes sir.
What is meant by saying distance between 2 points in calculus? Distance between x comma y and x naught comma y naught. What is distance between 2 points?
Square.
Yes. Array, you are in MSc. You should know what is
Sir,
distance
sir,
between 2 points in calculus.
under root x minus x naught whole
X
square
zero whole
plus y minus y naught whole square.
Very good. So, and this delta we will take, we will show that the same delta will work for this limit also, right? So we show this delta greater than 0 works. That means let the x comma y is approaching to x naught comma y naught is same as square root of x minus x naught whole square plus y minus y naught whole square is less than delta. Is that clear? Yes or no? That is same as saying that
Yes, sir.
distance between x comma y, which is, and x naught comma y naught. Okay. Now somehow we want to show that this distance between u minus u naught is less than epsilon. Is that clear? Yes or no?
Yes,
Yes
sir.
sir.
Yes, sir.
So we write everything beginning, you can understand. So we will show that u minus u naught is less than epsilon. Then we are done for limit of u, right? But if you take
Yes,
this
sir.
one from here, what you will get? This mod x minus x naught whole square plus mod y minus y naught whole square under root is less than delta is same as saying this one or not? Whether these two are same, are they both are same or not?
Yes, sir.
Yes, sir.
Because it is just like a
Yes, sir.
complex
Yes.
number, and we know absolute value of a complex number is this one. Is this clear? Right?
Yes, sir.
Yes, sir.
So
Yes, sir.
square root of mod x minus x naught whole square plus y minus y naught whole square is less than delta is same as, in just a notation, that x minus x naught plus I times y minus y naught is less than delta. This implies, we know already this, whenever this is true, we know that this is true. Is this clear? So what we can immediately conclude, u minus u naught plus I times v minus v naught is less than epsilon. Okay. From this, now can you somebody tell why this is true? From this, can see somebody see why this is immediately true? What is relation between this mod u minus u naught and left hand side of this inequality? This u minus u naught is already here or not? Which is real part of this whatever complex number you call. Are you following?
Yes, sir.
Yes.
So real part of any complex number is always less than or equal to, when you take absolute values, is less than or equal to absolute value of that one. Is that clear? That means what I am saying, u minus u naught, this is always less than or equal to u minus u naught plus I times v minus v naught. Yes or no?
Yes, sir.
Yes, sir.
Yes.
But we know that this right hand side, whatever we have, is already less than epsilon. Right? This shows that the left hand side is also less than epsilon. So same way, similarly, what we can prove, v minus v naught, which is again less than or equal to the same element u minus u naught plus I times v minus v naught, which is less than epsilon. This implies mod v minus v naught is less than epsilon. Very simple one we have elaborated. Is this clear?
Yes, sir.
What about converse? Conversely, assume that limit x comma y tending to x naught comma y naught, that u of x comma y is u naught, and limit v of x comma y as x comma y tending to x naught comma y naught is equal to v naught. Right? Then what we want to show, the limit of f of z as z tending to z naught is equal to w naught.
W.
So again, how we will proceed? If whenever we want to show that limit is equal to something, take an epsilon and find some delta. Is that clear?
Yes, sir. Yes, sir.
Can somebody
Yes, sir.
guess what should be the idea here? So start with let epsilon greater than 0. Then how we will proceed? From this point, two limits are given to us. What are those two limits?
U naught and V naught.
Yeah. So u of x comma y, limit of this is equal to u naught. This implies what you will get? There exists
U
some
minus U
delta
naught
that you
equal
can
to
call it as delta 1, and similarly for this limit you will get delta 2. So there exists delta 1, delta 2 greater than 0, such that what we will have?
so that U minus U naught is less than epsilon whenever
Whenever what this distance, that is the normal Euclidean distance, right? Such that
that is less than epsilon.
so u minus u naught is less than epsilon. Yes or no?
Yes, sir.
Yes, sir.
Yes, sir.
Yes.
And u minus, so if you want you can take epsilon by 2, but you can take epsilon also, there is no problem. And similarly v minus v naught is less than epsilon whenever, because both are same, so whenever distance between x comma y and x naught comma y naught, which is square root of x minus x naught whole square plus y minus y naught whole square is less than delta 1 and
Delta 1. Delta 2.
this x minus x naught whole square plus y minus y naught whole square is less than delta. Okay. Now, whenever there are some two different values, delta 1 and delta 2, we want something which works for both. So obviously, how we will take?
Minimum of them.
Yeah, minimum. Take delta as minimum of delta 1 and delta 2. Then we show that this delta will work for our f of z and w naught. That means what? We will take that delta such that mod z minus z naught is less than delta. Is this clear? So
Yes, sir.
Yes, sir.
let mod z
Yes, sir.
minus z naught less than delta. For these points, we'll show that mod f of z minus that w naught is less than epsilon. Is that clear? Yes or no?
Yes, sir.
But this
Yes,
is same
Yes,
as
sir.
saying that again
Yes, sir.
it is x plus iy minus x minus x naught minus iy naught. Sorry, this is plus I. Is less than delta, right? This is same as saying that mod x minus x naught plus I times y minus y naught is less than delta. Okay, this is same as square root of x minus x naught whole square plus y minus y naught whole square is less than delta. But delta is minimum of delta 1 and delta 2. So therefore, if something is less than delta, then it is also less than delta 1 and also less than delta. Is this clear? Yes or no?
Yes, sir. Yes, sir.
So
Yes, sir.
therefore, this condition, whatever we are having, is satisfied. Here it is satisfied or not? Huh?
Yes, sir.
Yes, sir.
Yes.
So therefore, mod u minus u naught is less than epsilon and mod v minus v naught is less than epsilon. Is this clear?
Yes, sir.
So therefore, now
Yes, sir.
mod f of z minus w naught, which is same as mod u plus iv minus u naught minus iv naught, which is same as u minus u naught plus I times v minus v naught. Now we can apply triangle inequality. This is less than or equal to mod u minus u naught plus modulus of I value is 1, which is same as mod v minus v naught. Is this clear? Huh?
Yes, sir.
Yes or no?
Yes, sir.
Yes, sir.
But mod
Yes.
u minus u naught, what we know? This is less than epsilon, and here it is less than epsilon. So if you take their less epsilon epsilon, you will get 2 epsilon here. Okay. So for that reason, what you can do here, you can start with epsilon by 2 and
Epsilon by 2.
epsilon. This is only manipulation. You can write there, then you will get here 2 epsilon. There is no problem, which is equal to epsilon. First, this result, right? Therefore, limit of f of z as z tending to z naught is w naught. Okay. So we have given a relation between f of z tending to w naught in terms of u and v. Okay. So if you simply give a notation instead of writing every time limit limit limit, so we just write as a remark, or we just use, we denote limit f of z z tending to z naught is equal to w naught by f of z tending to w naught as z tending to z naught, and limit u x comma y, where x comma y tending to x naught comma y naught is equal to u naught simply by u tending to u naught. This is understood. Okay. Similarly, v tending to v naught. Are you following? So whenever we are talking about complex numbers, then z tending to z naught as a complex number. This u naught, they are real values. So as x comma y tending to x naught comma y naught. Okay. With that, now you can have this algebra of limits. So let limit f of z as z tending to z naught say equal to w naught, and the another function that you call it as capital F of z, or if you don't want to use capital F of z, you can take small g of z. Both are same. There is no simply notation, that's all. Equal to say capital W naught. Then what we will have is sum of these two. That means limit of f of z plus capital F of z as z tending to z naught is same as this W naught plus this one. Okay. That means limit of sum of the functions is sum of the limits. Similarly, for product f of z into capital F of z as z tending to z naught is same as W naught times this capital W. Okay. And third one is wherever capital F of z, that means if f of z is this is capital F of z. So if capital F of z is not equal to 0, then the limit of f of z upon capital F of z as z tending to z naught is equal to the small w naught by capital W. Is statement clear? It's simply algebra of
Yes,
limits.
sir.
Limit of sum of
Yes.
the functions, limit of product, limit of the quotient, right? Here we no need to prove again by epsilon delta, because the relation we have established limit of complex valued function in terms of limit of real values. So we can, and we know already limit of real valued have this algebra of function. Algebra, is that clear? Yes or no?
Yes, sir.
That means limit of
Yes,
u1
sir.
u1 plus u2 is same as limit of u1 plus limit of u2 and so on, right? That we can use and we can find. So what is given to us? Limit of this f of z as z tending to z naught is equal to w naught, right? Implies this is same as saying that I'll simply write that is limit of u, okay, as x comma y tending to x naught comma y naught is equal to u naught, right? And limit of v of x comma y, okay, is same as v naught. Of course, this is same as saying that. So in simply we use instead of writing every time like this, for simplification, we say that u going to u naught and v going to. Is that clear? This notation, is this
Yes,
clear?
sir.
Okay. Then
Yes,
by
sir.
using
Yes, sir.
calculus, what we know? We know that u plus v tends to u naught plus v naught, u minus v tends to u naught minus v naught, and so on. Is this clear?
Yes, sir.
Yeah. So then similarly product, all those things we know about u and v very well now. Limits, algebra of limits of this u and v. Now you find out what is f of z plus capital F of z as a complex one. Now this f of z plus capital F of z is, if you write this as u plus iv, this is f, and capital F is capital U plus I times capital V. Okay, so we have not mentioned what is that. If you write in this way, then this is same as if you club together with real parts, this is u plus u and I times v plus v. So whatever you are having, this f of z plus capital F of z is this way. Is this clear? Yes or no?
Yes, sir.
So
Yes,
Yes,
therefore
sir.
limit of this one is same as what? Therefore limit of f of z plus capital F of z as z tending to z naught is same as limit of u plus limit of this one or not?
Yes, sir.
Because that w naught, which is nothing but
yes,
This limit is u naught and this limit is v naught. Are you following? So this is same as u naught plus capital U naught plus I times this. Okay, so we are using this result. This one we are using. Yes or no?
Yes, sir.
Yes, sir.
Because this u tends to u naught and v tends to v naught, capital U tends to capital U naught and capital V tends to capital V naught. So here you can write since u tends to u naught, similarly capital U tends to capital U naught. This implies u plus u tends to u naught plus this one. Is this clear? Yes or no?
Yes, sir.
Similarly, this v plus v
Yes,
naught
sir.
tends to this. So the real part and imaginary part too tends to that. So therefore, limit of this one is complex number of that. Okay, that means what we are using? We are using the converse of this result. Whenever this limit of this is u naught and limit of this v is v naught, then limit of f of z is w naught, which is u naught plus I times v naught. Is this clear? Yes or no?
Yes.
Ah,
Yes, sir.
Yes, sir.
yes.
Yes, sir.
But this is same as if you rewrite this one, which is u naught plus I times v naught plus capital U naught plus I times capital V naught, which is again same as this is this is what? Limit of f of z, small f of z, but that is nothing but
Plus limit of
limit of f of z, which is w naught, and this is capital. Okay, so this is same as w naught plus capital W, right? Similarly, if you want to find limit of that one, first you find what is this and see whether right hand side whether it is converging or not. F of z times capital F of z, which is what? U plus IV times capital U plus capital I times capital V, which is same as U times U minus I square, which is 1. So V times V plus I times U capital V plus small v capital U. Is this clear? Yes or no? Now, how we can argue? As this U capital U minus V capital V, this tends to what? This tends to U naught and this tends to V naught and V naught. Is this clear?
Yes, sir.
Because we know about real. So then we are trying to get for complex. And similarly, this U times V plus V times U tends to U naught V naught plus V naught U naught. You will get whatever right hand side, because left hand side you have limits. So therefore, limit of f of z times capital F of z as z tending to z naught is same as this limit of this one, which is u naught v naught minus v naught. This is u naught. This is u naught, v naught, and v naught plus I times u small u naught capital V naught plus small v naught and capital U naught. Is this clear? Yes or no?
yes, sir.
Yes, sir.
This again you
Yes, sir.
rewrite in this way, then you can check that this is same as W naught into capital W, right? So in the same way we get limit of f of z upon capital F of z as z tending to z naught. Of course, whenever capital F of z should be non-zero. This is same as W naught by, right? So what we have used in this theorem is the whatever statement we have written, that so same statements we have used for real case ux comma y. We know for real case they are already true, then we are proving for complex it is true by using this theorem. Is this clear? That means every time we are simplifying right hand side, we are showing this value, that therefore it is same as limit of complex. Clear?
Yes, sir.
So
Yes,
if you conclude all these things, what you will get here is, we can write some as remarks. Obviously, first one, so you can say obviously by definition itself you can find limit of any constant c, complex number, constant complex number is same as c no matter what z tending to z. Constant c is constant. Why? Because c minus c is 0, we know it is less than epsilon. Are you following? So any delta will work. Second one, limit of z as z tending to z naught. What should be this value by definition? So obviously,
Z
what is
naught.
z naught? Very good.
Z
Z
naught.
naught.
So what is your delta? Given an epsilon, what should be your delta? Is same as epsilon? Is same as epsilon or not? Because this
Yes, sir.
is
Yes, sir.
this is mod z minus z naught, and this is also mod z minus z naught. Are you following?
Yes,
Yes,
sir.
sir.
Yes, sir.
Yes or no?
Yes.
So take
Yes, sir. Yes.
delta as same as epsilon. Given an epsilon, take delta, that will work. Okay. And now use this product. What can you say about? So what can you say about limit of z square as z tending to z naught? What can you say about this?
Z naught square.
Z naught square.
Z naught square.
Whether we have to use definition or we can use this previous property. The second property we can use or not? Your small f of z and capital F of z both are equal to z. Is this clear? Yes, or no?
Yes, sir. Yes, sir.
By previous theorem property 2. Is that clear? Yes or no?
Yes, sir.
So in
Yes,
general,
sir.
in general, limit of z power n as as z tending to z naught, what we'll get? As z tending to z naught. This is what? Z naught power n?
Plus 2n.
Yes. If you want, you prove this by mathematical induction. Right? Because it is true for 2, then assume for n, any n, then prove it for n plus 1. Right? Just use product every time. Now if you take a polynomial, how you can write as a polynomial? Let p of z, which is, say, call it a naught plus a1z plus and so on, an z power n, where an's are complex numbers. So it is a polynomial whose coefficients are complex numbers. Is this clear? Then what can you say about limit of this p of z as z tending to z naught?
P of Z naught.
P of z naught. Very good. Why? Is that clear why it is true?
Yes, sir.
Why it is true? Because
Addition.
you have to apply the previous properties, that's all. That means sum, this is same as limit of z going to z naught. What is our p of z? A naught plus a1z an z power n. Then you consider each one as individual function, then limit of sum of the functions is sum of limits. Is that clear? Yes or no?
Yes, sir.
Here if you want, you take
Yes, sir.
an not equal to 0. Here it is a all ais. Okay. Then this is same as limit of, this is a naught plus a1 times limit of z, which is z naught, plus and so on an zn power n, which is same as p of z. Is that clear?
Yes, sir.
Of course, you have
Yes,
to
sir.
prove or you take it as an exercise. So I can write here exercise. Show that limit of some scalar, some constant, that means some alpha times f of z as z tending to z naught is same as alpha times limit of f of z. Is that clear? Where alpha is a
Yes, sir.
scalar, non-zero, alpha is a complex number. That is, you can simply show from these results or not? Huh? Yes or no? If you call it limit of f of z as w naught, then you want to show that this value is alpha times w naught. Okay. But if this is equal to w naught, then u tending to u naught and v tending to v naught. So alpha times u tends to alpha times u naught and alpha times v tends to alpha times v naught. So therefore their sum tends to alpha times u naught plus I times v naught, which is same as alpha times w naught. Is this clear?
Yes.
It's very basic. You just have to write clearly so that you will understand. Okay. So these are all, because so many times we directly use limit of a this polynomial is nothing but substituting at that point. Okay, substituting that point in that polynomial. So next class we'll see something interesting, or you can call it as extended complex plane. Extended complex plane, because most of the time we require this. So what it is nothing but C together with this called, this point is called point at infinity. So we'll take this point at infinity. We know already for a very complex number what is meant by neighborhood. So we will define here what is meant by a neighborhood of this infinity. Okay. So we'll define next class what is meant by neighborhood of infinity, because we know already what is meant by neighborhood of any complex number. Is that clear? If you want to call it
Yes, sir.
epsilon neighborhood of infinity. And we'll also discuss here, just like how we have discussed about limit of f of z. So far we used to write z tending to z naught. Now we'll see what is meant by limit f of z as z tending to infinity. How we can define this. Is this clear?
Yes, sir.
And we also see
Yes,
what is
sir.
meant by limit of f of z as z tending to z naught instead of w naught, which is a complex number. Now if we have this point at infinity, what is the meaning of this? We'll give equivalent known things using this. Okay. So I'll stop here and we'll see in next class. Please go through the whatever every day, whatever we are discussing. Please go through it so that you can understand better. And it is not possible every time to stop and ask whether you have understood or not. Wherever you have difficulty, you stop and ask me. And after lecture, because these videos will be available on YouTube, so please go through it and write down your notes. By watching the video, pause it. If you have any difficulty, you watch that video and pause it, and without looking that video, you write down. Okay, that is the way you can learn
Okay, sir.
things properly. Okay, we'll stop here and we'll see in next class.